Let's continue with number 14. It says the bacteria in a culture are decaying exponentially with time, as shown in the following table. Which is the correct function that will give you this table? That means that if you plug in a 0, which function or which equation will give you 500? If you plug in a 1 into the t, which equation will give you 200? And if you plug in a 2, which one will give you 125? So I'm going to start with 0. I'm going to plug in a 0 for the t. Let's go and start with the letter A. Y is equal to 1000 multiplied by 1/2 to the 0 power. Now 1/2 to the 0 is equal to 1. So 1000 times 1 is 1000. Does it give you 500? No. I'm going to continue with the next one. Y is equal to 500. I'm going to plus 1/2, but instead of the t, I'm going to plug in a 0 again. It should give me 500 if that's correct. This is 1. So 500 plus 1 is 501. Does it match? No. Let me continue with letter C. I'm going to plug in a 0. So it'll be 1/2 to the 0. 1/2 to the 0 is just 1. So no. Let me try the last one. Y is equal to 500 multiplied by 1/2 to the 0. Anything to the 0 power is equal to 1. So 500 times 1 is 500. That works. Now you also want to plug in the next number. Let's go and plug in a 1. So y is equal to 500 multiplied by 1/2 to the 1. 1/2 to the 1 is 1/2. And if we multiply across, that'll be 500 times 1 is 500. 1 times 2 is 200. And that's 125. So it does match. This is 250. So it does match. And if you want to plug in a 2, it should give you 125. Problem number 15. A certain radioactive element decays over time according to the following equation, and they're giving us an equation where A is the number of grams present initially, and T is the time in years. Now we just need to plug in the information that's given to us. 3,000 is the initial amount, and we want to be able to find out how much will it remain after 9 years. So because it decays, using this equation, we just can plug in the information. T will be equal to 9. Y is equal to 3,000, 1/2. T is 9 over 3, so we just plug in the 9 into the T, the 3,000. So Y is equal to 3,000, 1/2 to the 9 divided by 3 is 3. Now be careful, some of you guys are not writing this small enough to be an exponent. You multiply like a big 3. Now we're going to expand it 3 times. So Y is equal to 3,000. And I'm going to rewrite it once, twice, 3 times. I'm going to multiply across because this is a whole number. I'm going to place over 1. So 3,000 times 1 times 1 times 1 is 3,000. 2 times 1 times 2 times 2 times 2 will give me 8. And let's just go and do the long division here. 3,000 divided by 8. 8 goes into 30. 3 times. 3 times 8 is 24. 6. Bring the next 0. 8 goes into 60. 7 times 8 is 56. 8 goes into 40. 5 times. So there will be 375. And the last one, we need to be able to says if the following equation is graphed, so we need to be able to graph it. Which of the following values will produce a point closest to the x-axis? So I want to be able to graph it. Now, you need to think, is this an exponential growth or a decay? What would the graph look like? Now, if you are not sure what it looks like, we can always make a table of values just to be able to determine the shape of the graph. And then we can answer the question. I'm going to plug in values for x. I'm going to use that function 2 to the x power. And you can place it in parentheses if you want. Now I'm going to plug in a 0. That'll be 2 to the 0 power. Anything to the 0 power is equal to 1. And I'm going to plot the point. So if x is 0, the y value is 1. Now I'm going to plug in a 1. 2 to the 1 power. Anything to the 1 power is just itself, so it's 2. So if x is 1, the y value is 2, which will be right here. Now let me plug in a 2. If x is 2, 2 to the second power is 2 times 2, which is 4. So it'll be 3, 4. Now if you guys notice, it's starting to take shape. Let me plug in one more. I'm going to plug in a 3. That'll be 2 to the third power, which is 8. 2 times 2 times 2 is 8. So if I plug in a 3, the y value will be 8. And let's assume that's all the way over there. So if you guys notice, this is going to be an exponential growth. Now the question is, which value will produce a point closer to the x-axis? So we have this point here. If you notice, which ones will the smallest numbers or the biggest numbers will produce a point closer to the x-axis? Correct, the smallest numbers. As you get smaller, this value is again smaller and smaller, and it's getting closer and closer to the x-axis. So we're looking for the smaller number. I know that 1/2 is 0.50. I know that 3/4 is 0.75. So I know it's not big. I'm looking at something that's smaller than 0.5. Let's try 8 divided by 9. 9 goes into 8 0 times. I is 0. 9 goes into 80 7 times. 7 or 8 times. 8 times 9 is 72. Gives me 8. And so it'll be 0.88. Okay, so it's not this. Still, the smallest number up to now is 0.5. Now let's go and do 2 divided by 5. 5 goes into 2 0 times. I is 0. 5 goes into 20 4 times. 4 times 5 is 20. Subtract the 0. So the smallest number will be C. Now be careful. On the practice test that we did in class, that was an exponential decay. So we have 1, 2, 3, 4. As we get bigger numbers for the value of x, the graph is getting smaller. So it's going to be the opposite. So if it's a decay, we're looking for the bigger number. If it's a growth, we're looking for the smaller number. Or you can either memorize it, or you can just sketch the graph. You know how it should look, or you can make a table to be able to build a sketch, just in case you forget what the graph looks like, or how the graph behaves. So this will conclude the lesson for today. Have a great day, and please come by early if you have any questions. Remember, I'm not going to be reviewing during class. Thanks for your time.